Okay, so this video is about prime factorization using the Casio fx-260 Solar 2. First, we need to know our prime numbers: 2, 3, 5, 7, 11, 13, 17, 23, and it keeps going. We don't know how far, actually. Prime numbers are numbers that basically cannot be broken down with other numbers. For like example, 6. 6 can be composed with prime numbers, 2 times 3. Prime number starts with 2, and it's divisible by themselves or 1. So 13 can't be broken down into prime numbers because it's already a prime number. Those numbers that can be broken down with prime numbers are called composites. So for example, 10. We can break down 10 very easily. We know that 2 will go into 10 because this ends up with 0. So one way I like to do it is I like to put a bracket here and go 2 goes into 10, and we can say 10 divided by 2 equals 5. Perfect. So 10 is broken down into prime numbers, 5 times 2. Let's say 50, right? Let's break down 50. It ends with 0, so we know that 2 goes into 50. 50 divided by 2 equals 25. And we look at our prime numbers, we know that 5 will go into 25, if you know your multiplication tables. So we're going to divide by 5, gives you another 5. So 50 is really 2 times 5 times 5, but we can say 2 times 5 squared to make it just nicer, more compact. So 50 is composed of these numbers. Now you might have seen this differently, where you use arrows, right? 2 goes into 50, 25. 5 goes into 5. 5 goes into 25 5 times, and then you would have this. Yes, this is pretty cool, but sometimes I would forget to circle all the prime numbers. Here I can see them on the outside. Here I can see the last number will be a prime number. Okay. How about 350? Okay. I know 2 will go into it, right? Because it ends with a 0, so 350 divided by 2 equals 175. This ends in that ends in 5, right? So I can use 5 because it's part of my prime numbers. So divide by 5. It gives you 35. We know 5 will go into 35 because they divide by 5 again. Gives you 7, which ends up to be 7. You can see that this stops at 7, right? 350 equals 2 times 5 squared times 7. It ends up at, it stops at 7, right? It stops at 7. Can we figure out before we start what number it might stop on? Or what is the most it can stop on? Well, if you take the square root of 350, so you go 350, right? And then you take the square root, which is over here, a little bit hard to look at, shift x squared, right? Gives you 18.7. The closest, right? Well, actually, there's 19 here. Don't forget 19. I forgot. So the closest will be 19, right? So 19 is the highest number or highest prime number that can possibly go into 350. But we end up at 7. Okay. What about 101? Right? Does 2 go into 101? No. All right, 101 divided by 2? No. Does 3 go into 101? 101 divided by 3? No. How far should I go, right? Because this is 23, it goes much higher. Well, it turns out again, if you take the square root of 101, and then shift x squared, gives you 10.04, which is approximately what? 11. the prime number 11. We can go up to, so we can do 2, 3, 5, 7, 11. And if none of these numbers go into 101, it's going to be prime. So we did 2, right? 101 divided by 5, nope. 101 divided by 7, nope. 101 divided by what? 11, nope. So this is prime number. So it's part of this list. Sorry about this, 19. Probably somebody said, hey, 19. Okay. If you take, let's say 50 divided by 350, right? Can you reduce it? Yes, through prime factorization. So 50 is 2 times 5 times 5. 350 is what? 2 times 5 times 5 times 7. This cancels out, this cancels out, this cancels out, and this becomes 1 over 7. So if we do it on the calculator, 50, ABC 350, enter, 1 over 7. So your calculator can easily reduce fractions, but you can use prime factorization to do it by hand. I hope this is something that is useful. Please give it a thumbs up. Please subscribe. Please tell your friends. Please tell your teachers to look at this video, to share it with their students or with your schoolmates. I hope you have a great semester. I'll see you later. Bye-bye.